So dear students, in this chapter we are going to discuss simple microscope. So this chapter name is optical instrument, and in which we are going to discuss simple microscope. First we will discuss the power of accommodation. The power of accommodation, number one. Number two is D, that is minimum distance of distinct vision. So our optical instrument, our natural optical instrument like eye, it adjusts its focal length, adjust its focal length to view the object. Suppose this is eye, and object u naught is placed 40 meter from it. I can see it. If the object is displaced to 80 meter, the eye is going to adjust its focal length from 40 meter to 80 meter. This is known as the power of accommodation. The adjustment of focal length according to the object distance is called power of accommodation. And the next one is the minimum distance of distinct vision, that is D for human or normal eye. Normal height is 25 centimeter. Means if you decrease or take the object from 40 centimeter to uh, nearer to the eye, means 30 centimeter, then 28 centimeter, then 25 centimeter, then 20 centimeter. uh, Before 25 centimeter it can see the object clearly. After or near to the 25 centimeter or 20 centimeter, the eye cannot adjust its focal length. So minimum distance up to which the eye can adjust its focal length is known as plus D, or minimum distance of distinct vision, and for the normal eye it is 25 centimeter. Thank you. Then we will proceed the simple microscope. Simple microscope or magnifying glass. So the main objective is to increase the visual angle, to increase the visual angle. So these optical instrument, whatever may be, the simple microscope, the compound microscope, or the types of telescope that we are going to discuss, that will increase the visual angle. So first we'll discuss few things about the simple microscope. What the simple microscope does is the angular magnification. It does the angular magnification. Angular magnification. that is equal to angle subtended by the final image, angle subtended by the final image to the angle subtended by the object at when placed at D. D means the minimum distance of distinct vision. And one more thing, this is the magnification or magnifying power M, that is denoted by capital M. Next, the optical instrument whatever we are going to discuss, that does the line angular magnification. And we have another type of magnification, that is linear magnification and transverse magnification, that is out of the scope from our chapter. So here we will discuss angular magnification, that we have already written the formula. So to view object clearly from a naked eye, the object must be placed in between D and infinity. To view the object with naked eyes, the object must be placed in between D and infinity. So first we will discuss theta naught, that is equal to h by d, that can be described by this figure. This is theta naught, this is h, and this one is equal to d, and this one our I. So what the optical instrument or the simple microscope does, it increases the visual angle. So the visual angle, the increment, after increment it will theta is equal to h by ue. So that can be further increased by introducing a converging lens. That can be further increased by introducing a converging lens in between eye and the object. So the modified picture can be write like this. This one is the converging lens, right? This one is the magnified image, and this one is the eye. So the angle is visual angle is magnified from this to this to this. This is the previous height, and after magnification the height is like this. Right. Then we must go for that is the theta naught and that is the theta, and the magnification is it a division of two thetas, theta by theta naught, that is equal to h by u naught by h by d. After cancellation we can get d by u naught. And the two cases that we are going to discuss here: magnification for relaxed eye. So u naught is equal to f, that means m infinity is equal to d by f. So for relaxed eye, the object must be placed at infinity, right? And the second condition, this one is the first, and so the second condition is magnifying power when the object is placed as d, at d. Magnifying power when the object is at d. D means minimum distance of distinct vision, that is 25 centimeter for normal eye. So for the derivation of magnifying power of a simple microscope when the object is placed at d, we have to use the lens formula. The lens formula is like this: 1 by v equal to 1 by u is equal to 1 by f. The v is the v, u and f are already known to us, so this can be substituted by the value, that is 1 by minus d is equal to minus of u naught is equal to 1 by f. The equation can be modified by 1 by d plus 1 by u naught is equal to 1 by f. For proper equation to get, we have to modify the equation dividing d throughout. Dividing d throughout means from right hand side and the left hand side we have to divide d, that is d by d plus d by u naught is equal to d by f, right, is equal to minus 1 plus, that is d by u naught is equal to d by u naught is equal to m we have got, then d by f, and m is equal to 1 plus d by f. This is the required expression for magnification when the object is placed at d. Thank you.